All right, so today our notes are kind of a refresher of something we've done before, but now, of course, like in math, we're gonna kind of take it to the next level. It is called combining like terms. To combine like terms, or for something to be a like term, they must have the same variable or letter. And then the variables must have the same exponents. Remember, exponents are the little numbers that are raised, that are higher than the rest. Okay, so we're going to simplify each expression. We're not going to do all of these. I think we're probably going to do the left-hand side now in notes, and we'll do the right-hand side in class. Okay, so we look at this number one. I see the first term has an n in it, but if you look at the rest of the terms, so there are three terms. Let's start talking about that first. We got a negative 5n, a negative 2, and a negative 6. Look at the first term, it has an n in it, but neither one of these terms have an n in it. So negative 5n doesn't have any like terms, but these are both numbers that have the same variable because they don't have a variable. And if the variables must have the same exponents, well, again, we just said they don't have a variable. So they're just numbers or constants. We're going to put them together. We're going to combine these two. So I don't have anything to combine negative 5n with, so I'm just going to bring that down. And then a negative 2 and a negative 6. If you'll punch that into your calculator, I'll do this one. I'm not going to do all of them on my calculator. But I've got a negative 2 minus 6 gives me negative 8. So that's it. Make sure when you're finished with these, check and make sure there are no like variables, and there's not, so I'm finished. All right, so number 3 gets a little bit tougher. If you notice, this one has parentheses. What do I do with a number outside of parentheses? I'm going to take it, and I'm going to distribute it throughout. So 5x, I've got a negative 2 times 5, that gives me negative 10. I've got a negative 2 times 8x, gives me a negative 16x. So now let's look at my terms. I'm not finished. I've got this first term that has an x, so this one doesn't have an x, so these two are not like terms. But this one and this one are like terms. So I've got a 5x and a minus 16x. That gives me a negative 11x. If you wanted to do that on your calculator, I can't put the x's in, but I can put the 5 plus negative 16 in. Gives me negative 11x. So I'm finished with these two. That leaves me with a negative 10. So there's that one. So 5's a lot like it. I've got a number outside the parentheses. So I need to take this negative 6 and distribute. Go ahead and write my negative 2b. Negative 6 times 7b gives me a minus 42b. Negative 6 times negative 2 gives me a positive 12. My first term has a b in it, so now let's look for any other b's. There's one. They both have the same exponent, right? They don't have an exponent. Well, they do. It's really a 1. So those are like. So now I've got a negative 2 plus a negative 42, and that gives me a negative 44b. So you can punch that into your calculator one of two ways. I'm going to show you both ways. If you want to do addition every time, that works. I would put in negative 2 plus negative 42. If you don't want to put the addition, you could do it negative 2 minus. That minus right there, that minus takes the place of that negative. But either way, you get negative 44. I would recommend probably adding every time. Put addition between them, and then use the signs that you see. All right, so on number 7, let's compare to what we've already done. This one has 2 sets of parentheses. Well, all that means is I'm going to take the number outside the parentheses and distribute there, and then do it again there. So I'm distributing twice. Negative 7x times negative 7x gives me 49x. Negative 7x times 1 gives me negative 7x. I made a mistake. When I multiply variables, They both have an x. I'm going to add the exponent. So there's really a 1 there, and there's really a 1 there. That becomes a 2 there. X times 1 gives me plus x, it stays the same. X times negative 3x gives me a negative 3x squared. Okay, so now we have some exponents other than 1. I've got a 49x squared, so let's see if we see another x squared. That doesn't have a squared, so these two are not like terms. This one doesn't have a squared, so these two are not like terms. This one has a squared, that one has a squared. So I can punch in the numbers. I can do 49 plus negative 3. Remember, I can't type the letters in. That gives me 46 positive. That becomes 46 x squared. How I like to do it is I put a line under the x squared ones. And then I go back and look for some that have x's. Well, these both have x's. I'm going to put 2 lines under those. That just tells me that the ones with 1 lines are like terms. The ones with 2 lines are like terms. Now I've got a negative 7 plus a positive 1. There's really a 1 right there. That gives me minus 6. Last one. Like I said, we'll do these in class. So I've got a 5x out front, I'm going to distribute. I've got a negative 8y out in front that I'm going to eventually distribute. So this one's a hard one. I don't see us having one like this on the test, but if you'll notice, this one has x's and y's. All right, so I've got a 5x times y. Well, that just becomes 5xy. I've got a 5x times negative 8. That becomes negative 40x. Got a negative 8y times x, that becomes a negative 8. I'm going to write my letters in the same order, xy. And then I've got a negative 8y and a minus 3, that becomes a positive 24y. So now let's look at like terms. Okay, this one has 2 variables, but do I see any other numbers or terms over here that has an x and a y? Yes, I do. So I've got a 5 plus a negative 8. That gives me a negative 3xy. This one has an x. I'm going to put 2 lines underneath that. I don't see any other terms that just have an x. I'm just going to write that. And then this one right here has a y, but I don't see any other terms that have a y, so it doesn't have a like term. All right, and like I said, we'll do this side in class. So this, we're doing these a little bit different. All right, here's something that you really should be familiar with. But we really have to have a good understanding on it to do what we're going to do next. All right, so a relation. So we're talking about function notation and evaluating functions and graphs. A relation is any set of inputs that have outputs. A function is a relation such that every single input has exactly one output. A domain is all the possible input values, or the x coordinates. A range is all the possible output values, or the y. I'm going to show you a little trick in class to help you remember that. Input the number of seconds after the starting gun in a race to get an output of the number of meters. So after every second, this is how far this person ran. The domain, remember, is always my input, or my x's. Range is always my output, or my y's. So my domain in this case is, we got to do this little squiggly thing here, 1, 4, 7, and 8. And my range are all these numbers down here, 5, 20, 35, and 40. Observe the function y equals x minus 6, where x is the placeholder, also called a input, or for the input, and y is the placeholder for the output. So basically, if I take these numbers and plug it into this x, so negative 3 minus 6 gives me negative 9. 0, 0 minus 6 gives me negative 6. If I input these numbers into x, this is the output that is going to give it, or be given to me. So my domain, remember all my x inputs, negative 3, 0, 7, and 8. And then my range is all my y's, negative 9, negative 6, 1, 2, and put the little squigglies around it. I'm not very good at those, so I'm not going to grade you on how well yours look. The rule about only one output each time is crucial and must not be violated. So if you notice, I've got a 3 here that outputs a 4. I've got a 2 here and outputs a negative 1. I have a 0 here and outputs a 2. I've got a 3 here again. See how these inputs are duplicated? I can't have that. So I'm going to say it's not a function because an input of 3 is repeated. So if you look at your input and you ever see the same number twice, it is not a function. We're going to see what that looks like on a graph here in a second. All right, so each input must have one and only one output. So we're going to look at the graph and we're going to use the vertical line test. So no vertical line can pass through the points on the graph. 2 points on the graph, that's what it's supposed to be. Okay, so let's look at, we'll come back to this. Let's look at this one right here. If I took a vertical line on my pencil and I started moving it across this graph, does it ever touch 2 of these points at the same time? Well, sure it does. It would touch 2 points right there. So that one is not a function. So that's what it looks like on a graph. Now let's look at this. Just look at your x's. Do your x's repeat? No, I have a 3, a 4, a 5, and a 6. My x's never repeat, so that one is a function. Vertical line test on this one. If I take my pen or my pencil and it's my vertical line and I move it across this graph, it never touches this line more than once at the same time. It eventually touches the entire line, but never twice at the same time. So this one is a function. Let's look at a circle. Well, it touches twice every time. Once I get inside the circle, my pen would be touching here and here, here and here, here and here, here and here, right? So that one's not a function. So now let's talk about function notation. Function notation is f of x. F of x is a fancy way of writing y. So just remember, all you have to remember is f of x is really the same thing as y in an equation. It is pronounced, well, I just said it, f of x. All right, so here's an example. F of x equals 2x plus 4. So again, you can think of that as y equals 2x plus 4. It is the same as y equals 2x plus 4. So if my function notation is f of x equals 5x plus 2, my xy notation would be y equals 5x plus 2. The only thing that changes is if f of x becomes a y. So now let's go the other way. Y equals negative 3x minus 7. That becomes f of x equals negative 3x minus 7. So next, let's evaluate a function. I've got f of x equals x squared minus 2x plus 3 when x equals negative 3 and x equals 4. All this is telling me to do, ignore the f of x for right now, is figure out what this equals when x equals negative 3. So I'm going to take this negative 3 and I'm going to plug it into those x's. Remember, when we take a number to plug into a letter, use parentheses. punch it into your calculator. If you don't use parentheses on this first one, remember there was a square there. If you don't use parentheses on this first one, then it's going to give you the wrong answer. So you have to use parentheses. $18, so f of x, actually it would be f of, let me write, -3 equals 18. We'll talk about this notation in class. So now let's plug 4 in. Again, use parentheses. This time I'm going to do it a little different. So if you notice, the only thing that's changing here is I'm turning the x's into parentheses. And now I'm going to plug 4 into it. So f of x equals that. So let's punch it into our calculator. I've got a 4 inside the parentheses. I need to square it. -2, parentheses 4, plus 3. Hit enter, that gives me 11. So f of 4, basically when I plug 4 in for x, it's going to equal 11. And that does it for this video.